Alright, sorry for the delay, chat. I was late. Yeah, I was late to the stream. My apologies. So this is gonna be a very strange stream. This is very much a stream that I'm doing because I need to study, not because I need to make content. So, yeah, this is for me. You guys, I hate to say it, were an afterthought in this. However, that isn't necessarily a bad thing, because it's still going to be a good stream. You guys know how it's going to go. We are live for real now, so I can remove the message where I said we're going to be 10 minutes late, because we're not 10 minutes late anymore, we're 6 minutes late. Let me find some music to put on. Do you think I'll get copyright claimed if I play... Can I play like, what is it, jazz classics? Yeah, can we get some like instrumental jazz? Is that a thing on Spotify? Instrumental jazz. It is a thing. It is a thing. Cool, I'm hoping I don't get claimed. Bro, people from 60 years ago copyright claiming a CurtbroG physics revision stream. That'd be a new one. That'd be a new one. Yeah. All right. Okay. So we're revising physics today. Let's study. Hell yeah, let's study. Okay, so we've got the greatest website ever created right now on the screen. Physics and Maths Tutor. Literally the GOAT. Genuinely the best website for revision I've ever seen. We've got it. We've got it here. And I've got AS level physics. I've got the breadth paper tomorrow. Your library. Yes, I'm aware. I'm aware your library. You tell me like every time you join chat. I've changed. I took my glasses off. That's what's changed. I've started to realize I don't really need my glasses for looking at screens anymore. I don't get debilitating headaches like I used to. So I think my eyes have healed a bit. So I've tried taking my glasses off a little bit more, and it's been alright. It's been alright. I haven't worn them for a few days, so it's nice. As you can see, I've done 2016. I've done 2017. We're gonna hop into 2018. But the hair in your voice, yeah. I mean, my hair hasn't changed that much. It's just I've styled it different. Got the paper cut. Just finish your A-level exams. Cool. Of course, waiting for your results now. Nice. How you doing, Bingus? Welcome. Yeah, this isn't like, this is a mock, but it's an important mock. So, you know, I will. Anyway, I need to revise anyway. So I've been working on materials. Materials has kind of been the thing that I've been doing. Because yeah, I need to revise materials. But yeah, let's see. So I'm not doing this timed or anything because I want to like. This is more grasping the concept of like what's going on in each question rather than actually timing myself. So if I get my notebook out here, my notebook. So how I revise, I do a thing called active recall. So it's just writing the same thing over and over, just like spaced retrieval practice. So I've gone for about a notebook and a half of just, it's the same things written over and over again, just purely so I can remember them. And it's worked. Scarily it's worked. So like, I've been locked in. Anyway, question 1. Alright, the graph below shows the variation displacement S with time for an object. At what point does the object have maximum velocity? Alright, so velocity is going to be the gradient here. Because speed equals distance over time. Velocity equals displacement over time. Same thing. And the point with the most velocity, well, highest gradient, is B. Because it's might as well be a straight line going upwards. So, I'm saying B for that. Right, number 2. So, oh yeah, by the way, how a breadth paper is set out, you got 20 multiple choice, and then the rest of it is like full response questions for 70 marks. So, yeah. Which definition is correct and uses only quantities rather than units? Okay, so acceleration is a change in... Alright, no, that uses units. Resistance uses units. EMF uses units. Intensity doesn't. I'm saying it's C. I'm saying it's C. Yeah. Alright. A ball is thrown in the air. There's a column here for exactly, Kurt. Exactly. Right, a ball is thrown into the air. The ball experiences a small amount of drag compared to its weight. At a particular time, the ball is at point X. Which arrow best represents the direction of the resultant force when the ball is at X? Alright, small amount of drag, so it's going to be going backwards a bit. It's going to be experiencing gravity. It's going to be going... Well, no, okay, it's thrown. So it's curving, but it's not a straight. So it's not... I think it's B. Because if it's drag, the resultant force is going to be backwards. It can't be... Well, okay, put it this way. It can't be C, because then there'd be no drag. And it can't be D, because there'd be no drag. But it's a small amount of drag, so it can't be A. So I'm saying by process of elimination, it's got to be B. Intensity is power over area. Hell yeah! FIFA Sam might go. Of course it is. Yeah. Wait. Oh, that means I've got number 2 wrong. Hang on a second. Intensity is power over... Actually, no, that is right. Yeah, energy per unit cross-sectional area. Yeah. Yeah, no. I'm saying C. So, it's being said this whole stream. Yeah. So am I. So am I. Right. Oh, hang on. I've just remembered. We need to get the formula book. You're given this in the exam, by the way. I'm not cheating. You are just given this. So, yeah. Oh, that's the mark scheme. Oops. Right. An object P is traveling to the right with a momentum of 40 kilograms per second. So it climbs to another object Q traveling to the left. Okay. Final momentum is to the right. Right. So it's transferred 30 kilograms of momentum to Q. So, C. Because you have to conserve momentum. Momentum has to be conserved. Right. Wire P has length L, diameter D, and a resistance of 1 ohm. Another wire Q made from the same metal has length 3L and diameter 2D. What was the resistance of wire Q? Okay, well, if we go to this, we can look at resistance and resistors. So we're looking at the equation R equals rho, which is that funny looking P, that thing there. Rho L over A, because those are the units we've been given. So resistivity, which is rho, is going to be the same. So we're looking at 1, right, let's just say, okay, 1 equals rho, okay, so 1 equals rho L over A. Alright, we're happy with that. So we could also say, we'll say R equals rho 3L over 2A. Oh, sorry, it's diameter. Oh, no, that shouldn't change it. It should just be doubled. So you're dividing by double, but it's multiplied by 3. So it's going to increase by a factor of 3 over 2. So if we do 1 times by 3 over 2, that gives us 1.5. Therefore, I'm saying D as our answer. Hey Sam, how you doing? Welcome to the stream. Yeah, bro, I'm revising. I'm studying. I'm studying, bro. How do you do that? Because I took physics as an A-level. That's how I could do it. I'm going to move the camera a little bit now. That's how I could do it. 2 filament lamps, X and Y, are connected in series with a 16-volt direct current supply. The supply has negligible internal resistance. Lamp X emits a power of 2 watts, and lamp Y... You want to do a video? I should definitely lock... I am locking in! I am locking in! That's what we're doing. We're locking in. You just did your homework! Lamp X emits a power... You're done. It's power 2 watts, and lamp Y emits a power of 6 watts. What's the potential difference? Damn. Well, okay, so total power is going to be 8 watts. So, and power equals VI. So, 16 volts. So 16I equals 8. Because, so right, so the total power is 16. Sorry, is 8 watts. Total voltage is 16. And the current's got to be a constant. So by saying 16I equals 8, we can figure out I to be 0.5 amps. So that means if we take just the wattage of lamp X, which is 2, so we can say 2 equals V. Well, we could say half V. So therefore, V must equal 4 volts. Why is he on a gaming browser? Bro, it's just the one I have installed. I have Brave on my laptop. I use Brave on my laptop. It's just because it's the one I have installed on my PC. So I'm gonna say B for that one. Cause yeah, 4.0 volts. Alright, question 7. Two resistances 2 ohms and 4 ohms are connected in series across the terminals of a cell of EMF 1.4 volts and internal resistance of 1. What is the potential difference? Right, we're going to have to go back to this equation sheet. And our internal resistance has a very funky looking equation. And we're looking for voltage, so we're going to have the one with voltage. So, internal resistance equals V plus IR. And then we should be able to rearrange this to get our voltage, but it's across the 2 ohm resistor. So I think if we figure out the hang on, oh no, this is, oh damn, are we given current? We're not given current. Oh bro, we might be cooked. I don't know this one. Yeah, man, I don't know this one. Wild guess, but could we say total resistance is 7? So 7 must equal 1.4I, and then we can figure out current that way. Well, I mean, the numbers kind of work. 1.4 is a multiple of 7. So we do 7 divided by 1.4. We get 5 equals I. That doesn't seem completely unreasonable. So we can say the internal resistance of the external. You got me, man. You got me. Yeah. So I equals 5 amps, and then we can use the equation. We can rearrange. Actually, do we have to rearrange? Do we have to use this equation at all? Because we're not looking for internal resistance. We're looking for one on the 2 ohm resistor. If we can get the voltage, because we've got the current. Yeah, I think that's what we have to do. So V equals IR. So V equals 5 times 2, which isn't an option. It's not an option. I think we have to use that wacky equation. You know what? We can tank a mark. We can tank. This is for the first 20 questions. It's all 1 markers, so we can tank this mark. It's all right. It's all right. We'll skip this for now. We can come back to it. Okay, a student determines the power P dissipated in a resistor. The measured values of the current I in the resistor and the resistance R of the resistor are that thing there. P equals I squared R is used to calculate P. What's the percentage uncertainty? Alright, I love percentage uncertainty. So, 0.2 is, well, okay, let's do 0.2 divided by 4 times 100. So the first thing we've got to do is we've got to figure out the percentage uncertainty of the normal stuff. So it's 5%, so 0.2 is 5% of 4, and then it's 0.3 divided by 3 times 100 is 10, so that's 10%. And because it's I squared, we add that twice. So we do 5 plus 5, those are our I squared percentages, plus 10, which is our R percentage, which gives us 20%. So the overall uncertainty is 20%. And now the next thing we do is we actually do this equation. We substitute in the values. So P equals 4 squared 3, which gives us, if we put this into a calculator, this gives us an answer of 48. So P equals 48. And now 20% of 48 is 9.6. Wait. I've just done way more than I need to. I'm trying to figure out absolute uncertainty. Yeah, sorry. Ignore that last bit. It's 20%. It's B. Yeah, I'm trying to figure out absolute uncertainty. You need to find someone's address. Okay, alright, okay. Diagram shows a uniform rod at rest in a horizontal position. The rod is hinged at point X, cable attached to the vertical wall, and the midpoint of the rod, which arrows best represents. Okay, so this is just kind of logic. If you were to be in the position of the rod, what would be giving you the most amount of force? I think it would be D. It'd be C. It'd be a mix of C or D, I'd say. I don't think it's A. I really don't think it's A. I don't think it's B, because the cable's going that way. So it's like... You can ask Dwayne. Yeah. It's like, I think if you were at a rod, if you were the rod, I feel like it'd be C. I feel like it'd be C. Just off of vibes. Off of vibes, I think it'd be C. Alright, a car is driven at constant velocity until the driver sees an obstruction ahead at time t equals 0. The velocity against the time graph below shows the motion of the car as the driver brings it to a stop. The thinking distance is 10 meters. What's the stopping distance for the car? Right, so this bit here is 10 meters. So 1 square equals 10 meters. So it's a counting game. So 1, 2, 3, 4. So it's 4 squares, which is 40 meters. So it's 40 meters. C. Javelin throw exerts a force of 100 newtons on a javelin for a time of 0.3 seconds. The javelin has a mass of 0.8 kilograms. What is the rate of change of the momentum of the javelin? Okay, so this is an equation. F equals... Hang on, I'll show you. I have memorized this one, but I'll show you guys just so you know what I'm on about. It's this equation here. F equals delta P over delta T. Delta P is the change in momentum because... right, so in A-level, delta means change in. That's that little triangle there. So this is change in momentum over change in time. And momentum is mass times velocity. So what we can do here is we can get delta P over delta T. Rearrange this to get whatever equals delta P. So it'll be F delta T equals delta P. So we could just substitute the values in now. So 100... and then our change is 0 to 0.3 because you start at 0 whenever you count from something. So it's 0 times 0.3 equals our change in momentum. So if we do 100 times 0 is a high minus 3. Okay, Slumpic. Okay, man. And then this gives us 30 as our change in momentum, which is B. I'm going to change the lights. I can't see what I'm writing. There we go. And it's falling on the floor. Okay. Right, question 12. One of the wires fixed to a ceiling and a 3 kilogram object is suspended from the other end. The wire's diameter 0.62 and negligible mass. What's the tensor? Oh, stress. Okay, so stress is figured out by force times length. Now, we're not really given much to go off of here. Right, so I think we're going to have to determine both. Which I'm not... Let me look in the equation book. I think we'd be able to figure out... I'm not too sure. If I'm being completely honest, I'm not too sure how to tackle this one. Yeah, we're really not given much. We're given mass and diameter. I guess if we're given diameter, we're gonna have to figure out area. So force over area. Yeah, but we need to determine force. And we're not really given much to go on with that. Like, yeah, that's the equation we gotta use, but it's finding the force. I mean, we'll find area first. Area's pretty easy. It's for a circle, it's pi d. Our d being 0.62 millimeters. So convert that to meters. So 0.62 times 10 to the minus 3 times that by pi. That gives us roughly 1.95 times 10 to the minus 3 as our area. And then, yeah, we've got to figure out force. Kx. We don't know force constant or extension. Is there an energy one that uses... Right. Is there one that uses mass and then one that also uses force? I feel like there is. Mass times... You smart man. Thank you, you smart man. F equals ma. Completely forgot about that one because it's not in the formula book. So yeah, because it's we can use gravity. Gravity is 9.81, so we can say F equals 3 9.81. So 3 times 9.81. F equals 29.43 newtons. So we can say 29.43 over 1.95 times 10 to the minus 3 is equal to... should be equal to our answer. Which is 15,092.31 pascals. Which I think if you put that in standard form, that's A. Well, A is the only one with 1.5, so I'll say A. Alright, question 13. The intensity of light incident on a light-dependent resistor is increased, its resistance decreases. Which statement gives the correct reason for this behavior? Oh my god. Okay, it is that. Well, it's one of these. It's certainly one of these. Number dent? I'm just gonna guess a letter. It's fine. We'll tank that mark. It's all good. Alright, the total energy gained by 20 electrons traveling through a potential difference V is 30 kilo electron volts. What's the potential difference V? Okay. So we gotta convert between electron volts and potential difference. I feel like I've seen this question before. I don't really know. Hang on, no, I'm cooking something up. Right, if we do 30,000, which is 30 kilo electron volts, divide that by 1.6 times 10 to the minus 19, and then divide that by 20? No. If we do that the other way around, and then times it by 20. No. Okay, so neither of those ideas worked. That's okay. We live and learn. I think we'll come back to this question in a minute. A trolley of mass, 1 kilogram. Like, you gotta remember, these are 1 mark. Like, these, like, that is, like, just over 1% of the paper. Like, 1 singular percent. It's not that bad. A trolley of mass 1 kilogram is moving on the horizontal surface at a constant velocity of 2 meters per second. Force of 3 newtons is applied to the trolley in the opposite direction to its motion for a time of 1.5 seconds, and then the force is removed. What's the magnitude of the final momentum? Alright, okay, so we're looking at P equals mv. Right, we can figure out the initial momentum by doing 1 times 2, which gets us 2. So our initial is 2 kilograms meters per second. then a force of 3 newtons is applied for 1.5 seconds. So this is where our equation F equals delta P over delta T comes back in. Because then we can do the change in momentum, which once again is F delta T equals delta P. So it's what? 3 newtons for 1.5 seconds. So 3 times 1.5. Hey B, say no more to the stream. So that's 4.5 Newton seconds. No. No, kilogram meters per second. Why did I say Newton seconds? What's wrong with me? So that's the change in momentum. And to find out the change, find out the final, we do 4.5 minus 2 gets us... Oh no, we add it on. Sorry, plus 2 equals 6.5 kilogram meters per second, which is D. Oh no, sorry, opposite direction. Yeah, it's minus. Sorry. That changes it to B. No? Oh no, momentum scalar, isn't it? Yeah, just going the other way. Yeah, B. Yeah, B. It is in fact B. Okay, the current at a point in a circuit is 10 milliamps. Express the nearest power 10. How many electrons pass this point in 10 seconds? That's a great question. I don't know. Well, okay, current is... We can say current equals A and EV. And then that's the number of electrons and charge. We don't get voltage, do we? No. What grade levels were... I think technically this is 11th grade. But we call it year 12. It's sixth form. It's A level. It's A level. So we'll call it A level. So it's like grade 11 to grade 12 physics. Actually, does it matter? Does it matter if we're given voltage? No, it kind of does. I think this is one of the ones we kind of need to know. So... Hang on. Is there something up here? No, there is not. There is not. I'm just going to guess then. We ball. 10 to the 18's calling out to me. We'll go see. Electromagnetic radiation is incident on metal. The radiation has constant wavelength, with each photon having an energy of 5 electron volts. The work function of the metal is 3 electron volts, which cannot be the kinetic energy of the emitted photoelectron. Okay, so we're saying 5 equals 3 plus Ke max. So it can't be 3. It can't be 3, because then otherwise the energy is higher. Because if we look at this equation... Oh, I've gone past it. This equation here. So HF, which is E, because E equals HF. Phi plus Ke max. Phi is our work function. Plus Ke max. This cannot be smaller than this, otherwise that doesn't work. So it must be D, because 3 plus 3 is 6, not 5. Alright, question 18. We're nearly done with the multiple choice. Right, the waves emitted from 2 sources are coherent. What quantity must be constant for these emitted waves? Phase difference. Yeah, if they're coherent, they have a constant phase difference. Okay. And phase difference is let's say you have 2 waves that are like emitted at the same time, but one of them's a little bit behind the other one, but they've got everything else is the same about them. They would have a phase difference. Like, let's say, is this physics class? Yes, this is. So let's say, hang on, I'll draw it. Can we go like paint.net? Does paint.net still exist? No. No, it doesn't. I don't want paint.net. Go away. Oh, it's JS Paint. Sorry, I got the wrong one. Right, so like, for example, like that's an awful line, but let's say we got our wave going like this. If it was in phase difference, it would start a little bit back here, and then it would follow along the same, but it would be just out of phase. You see what I mean? So this bit here, this distance between, that's the phase difference. So like, for example, this could be like, we'll call this pi. So that's 90 degrees. And we'll call this... I know this is not to scale. But we'll call this like half pi. So that's 45 degrees. If we're working in radians. So yeah. Like, and so you could say the phase difference here is half pi. Because one starts half pi later. That's not a pi symbol. That's an ohm symbol. Or 45 degrees. That's what you could say. So you'd be looking at that one because you don't really use radians in physics. You use degrees when you're talking about sine waves and cosine waves and graphs and waves and whatever. So that'd be the phase difference, for example. And that would be constant. It can't change if they're coherent because then everything else must be the same about them. Right. The diagram below shows a stationary wave pattern for a sound wave in a tube. The tube has one open end and one closed. Oh my god, I hate these questions. The length of the tube is 60 centimeters. What's the weight? Actually, this isn't bad. So this is complicated. It is complicated. It is complicated. It took me a while to get my head around most of this. Right, so 60 centimeters is 0.6 meters. Let's start with the easy bit. So we're looking for an equation that links, its length and, well, wavelength. Oh, no, because, alright, so a stationary wave is that's half a wavelength. No, that's not half a wavelength. That's more than half a wavelength. That's more than half a wavelength. Is that like 3/4 of a wavelength? I think it is. Right, so that's 3/4 lambda. Lambda is wavelength, by the way. So if 60 is 3/4, the wavelength is 80. Hey, De Bruyne, how you doing? What's the stream? Yeah, wavelength's 80, because 80 divided by 4 is 20. 20 times 3 is 60. 60 is 3/4 of 80. Yeah. Yeah, it's D. It's D. Alright. Last one of the multiple choice. I'll mark what we've done so far after we do this question. Just because, yeah. Well, the correct base units for work done or energy. Alright, this is a pretty easy one. We can kind of just look at this. W equals QV. Well, VQ. Which is not on here. Oh, it wants the other work done. It wants work, not work done. So work is power over time. Or force times velocity. And force is MA. Which is kilograms meters per second squared. Times that by velocity again. That is not on here. Well, no, it's one of these two because meters will be squared. I think it'd be this one. I think it'd be D. Yeah. Okay. Well, that seems about right. Alright, let's pick up a pencil. Let's see what we got correct. Okay, cool, right. Nice. Alright, we didn't get that right. What was question 2? It was D. I wouldn't have guessed D. I would not have guessed D. Yeah. That's alright. Yes. Yes. No, we didn't get 5 right. It was... What was it? 5 was A? Oh, it was 2/3, not 3. Oh, I got it the wrong way around. I got it the wrong way around. Bro, no! Oh, I did 3/2, not 2/3. Oh, man! That's on me, guys. That's on me. It was A. Yeah. Right, 6, yes. 7. 7, no. It was not B. It was A. Wait, hang on. I've marked... Wait, what? Oh, sorry. No, I just didn't finish question 7. I forgot about that. Yeah, of course it's gonna be wrong. I didn't finish it. 8 is B. Yes. 9 is C. Yes. 10 is B. What's this? Stop. The thinking distance and what the hell? Huh? Kurt, do you enjoy Roblox? Kinda. Sometimes. I have to be in the mood for it, which I very rarely am, but yeah. Okay, so no, if 10 meters takes half a second, 10, 20, 30, 40. I stand by that. I think that should be 40. No, you can't. No, that's not 30. That's not 30. The stopping distance starts here. So it ends at 2.5. 0.5 times 2. Actually, doesn't work. What am I trying to say here? 0.5 times 2 times 10. No, once again, not what I'm trying to say. What am I know what I want to say, but I can't think how to put it. I should in streams there. That'd be cool. That would be, but I don't play Roblox that much. No, that I stand by the fact that that should be 40. I think I got that correct. I think I got that correct. That's the thinking distance. That's the stopping distance. The thinking distance with 10. So 10, 20, 30, 40. That's 40 meters. You cannot tell me that's 30. Oh, it's whatever. We didn't get 11 right either. 11 was C? I'm calling BS on this. How was 11 C? What? Oh no. I got caught out. 20. Yeah, but where are you getting the 2.5 from? That's the total time. So, yeah, 10 divided by 0.5 is 20 meters per second. So, wait, how? No. 20. Yeah, but it doesn't start until 2. Also, yeah. It doesn't start. Wait. No, it still should be. That bit there is 2 seconds. So yeah, the area under. Okay, let's do this a different way. Area under the graph. Area under the graph is distance traveled. So you can say base times perpendicular height divided by 2 is the area of this, if you make this a triangle. So that's 4 squares up. We don't know velocity. But it's the same as the bottom. I don't know where I'm going with this, actually. Yeah, no, yeah, that's not gonna work. I'm still adamant that this is... Because that line there, so one square... Yeah, 1.5, but still. One square... Yeah, one square is 10 meters. So, surely, that's another 10. So that's 10 of the stopping distance. That's 20, that's 30, that's 40. And then I think I see where I went wrong with this. Because, fun fact, I didn't read the question right. I figured out the change, not the rate of change. The rate of change is very much that, because the rate of change is delta P over delta T, so I need to rearrange it too. So yeah, no, I'll take that one. Yeah, I didn't get that one right, but if I do, I'll suffer. Bro, I'm suffering as well, man. I'm not having a good time. I dropped my pencil. 10, yeah, plus. Yeah, but isn't so 20 times 2 divided by 2? Yeah. Why are we dividing by 2? Actually, where are we getting 20 from? Where's 20 coming from? Yeah, so we got the bit here. We got this bit here. Breaking distance is a triangle, so it's half the area. So you've done the area. Yeah, so. But how are you getting 20? How do we know it's 20? Because we're not given the velocity. We're just given that there is 10 meters. Oh, I know, I'm an idiot. Yeah, you can't fit. Yeah. Yeah, no, you're right. Yeah. I've just realised you can indeed find out the velocity. Okay, yeah, cool. Right, let's move on. We've figured out where we went wrong. Right, question 12. I've fumbled these. We got 3 wrong in a row. It was D. It's a materials question though, so like they're mid as hell. I don't care. 13 C, 14. We just kind of left blank. 15 was B. 16 was C. 17 was D. Oh, we're on a comeback, boys. We're on a comeback. 18 was D. 19. Oh, we're back. We're so back. Right, so out of 20, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Alright, for the multiple choice alone, that's fair. That's alright. That's more than half. That's more than half, actually. I can tell you how much that is. That is 65%. That is an A there. If we stop the test there, that's an A. So we're so back. We're so back. Anyway, that's the multiple choice done. Let's go on to the real stuff. Alright, a trolley is placed on a long ramp and is released from rest at the top of the ramp. It travels to the bottom of the ramp with a constant acceleration. Describe how a meter rule and a stop... I think that's meant to say ruler. A stop which can be used to determine the final velocity V of the trolley at the bottom of the ramp. So, how... Okay, they've kind of just set it up for us. So, it's a 2 marker, so we can say... Place... so place meter ruler with fiducial marker adjacent to the trolley. Then when the trolley is Released. Start the stopwatch. And when the trolley, when the trolley reaches the bottom of the ramp, stop the stopwatch. Measure distance from fiducial marker to end of ramp, and then multiply. No, don't multiply. Divide distance over time. Time to get velocity. Oh, to get final velocity. Oh! Can I say can I say integrate the velocity to get the acceleration? Am I allowed to do that? Oh no, it'd be differentiate. Can I differentiate the velocity to get the acceleration, or is that not allowed? Because that's how it works. But I don't think I'm allowed to do that. I think that works. Yeah, because what, you got a distance, because then you can. Or you could somehow try and do a velocity. We'll leave this question because it's mid as hell. I don't like this question. Go to the acceleration. Oh, we actually have to do it now. Oh, that's okay. We given time? No, we're not. Oh, we're given like everything else though. Okay, so 2.5 minus 1.3. This gives us our change in velocity. So that's 1.2 meters per second is our change in velocity. So we can, and that's over 1.1 meters. We're on ChatGPT mobile. That's why he's looking down. Bro, you want to see something crazy? My phone is being used as chat. I cannot use ChatGPT mobile. I'm looking now because that's where my notebook is. Also, ChatGPT does get these kinds of questions wrong, which is funny. Right. So, yeah, so we've got the change of velocity. We're not given a time, unfortunately. But, yeah, 1.2 meters per second in 1.1 meters. So what? Could we do like 1.2 divided by 1.1? No. 1.1 divided by 1.2? I'm trying to think of like just a combination. So it's like, so in a second it'll go 1.2 meters. I think acceleration I think would equal 1.2 divided by 1.1, which is successfully located. Nice. Which is 1.09 meters per second to the minus 2. Okay. I did not like that question at all. Oh, it's not even done yet. Oh. Huh? The acceleration of the trolley down the ramp is equal to the component of the acceleration of free fall parallel to the ramp. Use the answer to BI to calculate the angle. For real? I don't want to do this. Where's Curtmouth? Oh, good question. Good question. Where is Curtmouth? I'm trying to get the webcam to be like a good point. Right. So. Bro, this is only a 2-marker. Don't make it this difficult to understand, bro. Acceleration of the trolley going down the ramp is equal to the component of the acceleration of free fall parallel to the ramp. Oh, that's actually really easy. Okay, it just wants me to draw a triangle and then solve it. But we're not given any of the lengths. Unless we just need to do it for X and Y, but that wouldn't make sense. They're the only things. Well, that would make a triangle. You know, yes, it would. And then yeah, that'd be theta. That'd be a right angle there. That'd be another angle. We could do sine rule. Because we'll know that's 1.1. We'll know that's 90 degrees. But we would need to find this out. Unless that's what we use as our acceleration. Okay. I'm cooking something up. So we want to find the angle, right? So we do sine. So we'll do sine 90 over 1.1 is equal to sine theta over 1.09. Hey Rafe, how you doing? Welcome to the stream. That's about the worst possible thing I can do, I think. No. I'm skipping this question. I don't know what it wants from me. It's too smart. It's too smart. What is this? I've never seen this in my life. 3 short legs of cord are tied together at point X. The other ends of the cords are attached to the ends of the springs and the object as shown in figure 2.22. The angle between the central of the springs is 90 degrees. The tension in each spring is the same and equal to T. The weight of the object is 4.8 newtons. The point X is in equilibrium. Stay and explain the magnitude. I don't know. If I'm telling you, I don't know. Biblically accurate spring. Yeah. Okay, well, actually, okay, so we're given 4.8 newtons. These are in parallel. So we could do... Would we need to do spring constant? Like, we could figure it out. We're not given the extensions, though. I think it's got to be going down. I can't do that one because I'm not doing it on. Actually, no, I could do that one. Is an equilibrium triangle? I've never heard of an equilibrium triangle before. Nah, for real? For real? I've never heard of an equilibrium triangle before. Hang on, what's a... Guys, I can't spell. triangle in which all sides the same length. Okay. Okay. It's just all angles are the same. Oh yeah, I can kind of see that. B is Pythagoras. Yeah, B is Pythagoras. Yeah. I think I'll be able to do B. It's just I can't do A. I've never heard of this question before. I've never seen this in my life. Oh my god, it's a 4-parter. No, that's not a compliment. So, if they're equal, it's going to be pulling in the same... Well, no, hang on, no, if it's equilibrium... If it's equilibrium, it's not good... Nothing's going to be moving. So... There won't... Because it's equal tension. So, nothing will be moving. So... The resultant force is 0 newtons. Well, actually, no. It'd be 4.8 newtons downwards. Because the other two cancel each other out. As the force in the springs are equal and opposite, cancelling each other out. That seems reasonable to me. This is just Pythagoras. Where's my ruler? Oh, it's in my pencil case. That'd help. And then what? We just draw a little triangle. Well, if it's an equilibrium triangle. I have to get point X. Yeah. So it's just yeah, it's just a triangle. Do I have to do angles? No. So it's like, so that's tension, and then that's, I don't need to draw a line there. Then that's W. Do I have to label normal contact force as well? Because that'd be at the top, I think. Well, no, it wouldn't. It wouldn't. You know what? I'm feeling crazy. I'm gonna add the angles in as well. Yeah, you know what? I think that's, considering I've not heard of it before, I think that's a reasonable thing to put. Sure. You know what, man? Why don't you shut up? I don't want to show the tension. Oh, I've got to remember tension now. T equals, was it mg minus ma? Oh, wait, hang on. I just realised I made a mistake. It is a right angle triangle. Right, well, we could do 4.8 over 9.81 to get the mass. But hang on, does it say tension in the spring? So 0.49 kilograms. So it's 0.49 kilograms. And then... yeah, the thing is, we're not given tension. Please tell me this is like the only question about this. Oh my god, man. I don't want to do up thrust. Oh my god. This is the worst past paper I've ever seen. Okay, it gets better at the very end, because space is mentioned. But the rest of this is the worst exam paper I've ever looked at, bro. My god. Okay, show the tension. Right. Tension equation. Oh, it's TG plus MA. What about tension in spring? Oh no, we're given everything we need. Oh no, we're given everything we need. Because A is just going to be 9.81. So, wait, no, that can't be right. Actually, no, that can be right. That can be right. So it's 0.49 times by 9.81 plus 0.49 times by 9.81. 9.61 divided by 2. Okay, no, that's not quite right. That's not quite right. In spring. Is there a different one? Yes, there is, but there's no extension. Welcome back, Kurt. W? Why is W here? Is that meant to be weight? Yes, it is. So it's T equals W plus MA. M equals 0.49. So it's 4.8 plus 0.49 times 9.81 divided by 2, which is 4.8. You know what? I'm skipping this. I hate this question. This question is the worst question. Calculate. Now you see, this is something I can do. Because T squared plus T squared is equal to W squared. Why would I know that? Bro, materials is genuinely the worst subject ever. Right, so 4.8 squared equals T squared plus T squared. For real? For real? Oh my god, no. We're taking a break, boys. We're taking a break. We're taking a break. We're taking a break. We're taking a break. Hang on, where is it? YouTube. Was it Summer Games Fest? Summer Games Fest. Where is it? Show on stream. Which stream? Which stream? Bro, you can't just tell us this! Doom Dark Ages. Okay, boys, we're taking a break. We're taking a break. We don't need the captions. We don't need the captions. This is peak. This is peak gaming. The music goes hard. Peak. Peak. It's the prequel? Oh my god. Peak. Peak. I will be there no matter what. Thank you for telling me, George. I will be there no matter what. Oh my god, I'm hyped. We're so back. We're so back. Gaming is saved. Gaming is saved. Try meatballs right now. I'm trying not to cry at this paper. Okay, so. Okay, right, so we can divide this by, so 23.04, which is w squared, can be divided by 2 to get 11.52, which is also equal to t squared. So if we square root the answer, that should get us, yes! Yes! And then t equals 3.39, which is approximately equal to 3.4 newtons. We're so back. We're so back. FIFA Sam might actually be the GOAT, for real. Right, force constant of each spring is 24 Newton meters. I know I can do this one because we use the equation F equals KX, okay? Actually, no, we don't. No, I'm lying. I'm lying, guys. I'm lying. Me when I purposely spread misinformation over the internet. We use, damn, what do we use? We give them force constant. That's like the middest thing they could give us. Oh, actually, no. No. No, if we... No, so we know the force in each spring now. So we can use F equals KX. Rearrange this for X. So F over K equals X. Substitute the values. So 3.4 over... what was it, 24? Yeah, 24 equals... 0.141. Roughly. No, 0.14... We'll round it 0.14 meters. That's our extension. And then we can use that in E equals half f of x. So we can substitute the values in again. So E equals half of 3.4 0.14. So we should be able to do half 3.4 0.14 equals 0.238 joules. That seems right-ish to me, kinda. We'll go with it. We'll go with it. God, that question's finally over. Let's go. So the general shape of the graph shown in figure 23.2. Okay, container slowly for... Right, let's go start from the beginning. Question about up-thrust and other forces acting on a sealed hollow tube in water. One end of the string is attached to the bottom of the tube, and the other end is... other end of the string is attached to the bottom of the container. The string exerts a downward force, F, on the tube. It's half submerged in the water at T equals 0. The container is slowly filled with water at a constant rate until the container is full. So this is force against time. Okay. Right, so by considering the forces acting on the tube. Right, so... Pretty sure density's going to come into this. Because that's mass over volume. Street enemy called Nethergator. Bro, let's go into the Nether. I'm genuinely so hyped for the new Doom. Genuinely, it's going to be peak. It's going to be peak. I know they haven't got Mick Gordon on the soundtrack, but like, they still got some good guys there. Like, Chad Mossholder is, like, solid. He did good work on, Ancient Gods. But like, how could you live up to Doom Eternal? It's looking like it will, which is amazing. But it's like, they're gonna have to go crazy. Or they could just make Doom Eternal 2, which I wouldn't be upset about. Anyway, back on topic. Right, so by considering the forces. So, at T equals 0, there is already... I think cool. Yeah, because I saw them in... that you could see them in Doom Eternal, and it was like... Now you actually get to go in one, which is amazing. It's great. So at T equals 0, there is already some... force as the tube is filled halfway. Was it a tube? No, sorry, container. Right, obviously there's a Doom trailer. That's a good question. That's a good question. So as more water is a pro player, but he's also thank you, GeoGust. How you doing, man? Welcome to the stream. So as more water is added to the container, more pressure is added to the string, as shown in the equation P equals F over A. Equals peak acting. Okay. Oh no, it'd be P equals H rho G as density increases from the equation rho equals M over V. This continues. Oh, hang on, I'm going to the wrong way. until t equals 60, where the container is full and no more water is added. Very cool. That's that question done. Right. B. Container is now full of water. The string is cut and the tube accelerates vertically upwards through the water. The weight of the tube is 0.8 newtons and the upthrust on the tube is 4.2 newtons. Calculate the initial upward acceleration A of the tube. Is this F equals MA? It's a 3 marker, so I think it's a bit more than that. Suvat? We wouldn't have anything for Suvat though. I mean, we could... No, we couldn't figure out mass, because it's suspended. It's not actually, like... Yeah, it's not F equals MA. Let's consult this. Let's see. Let's see. Because it's not going to be uniformly accelerated. No, it's not going to be anything to do with that. I think, if anything, it's going to be something to do with this. I'm not sure, though. I don't really know. I might come back to this. I might come back to this. Someone remind me, once we finish this question, to come back to this part B. Still, the acceleration of the tube decreases as it travels vertically upwards through the water. As the height increases, there is less upthrust due to the... to give it English word suffering. Yeah. Due to there being less water exerting pressure and force on the tube. Yeah, right, so I think we'll do the next question, and then we'll come back to part B on that. Someone remind me. I don't want to lose out on 3 marks that easily. A student is investigating an unidentified component found in the laboratory. The table shows the results from the lab book of a student. The potential difference across the component is V, and the current through is I. Calculate the power dissipated by the component when V is 10 volts. Is this for real? Is this for real? Is this as easy as it looks? Is this as easy as it looks? Is it genuinely 10 times 30 times 10 to the power of minus 3? It's looking that way. .3 watts doesn't sound completely out of the question. So... Huh. Analyze the data in the table and hence identify the component. So I was looking for an electrical component. I think we go through this process of elimination. So it can't be a thermistor, because current is constant in a thermistor and it's the voltage that changes. It can't be any of the NTEs, the negative temperature... NTCs, negative temperature coefficients. because that would be it would decrease. It would start high and then get lower. So I think we just start bullet pointing stuff. So the voltage and current increase the increases of the current get lower each time. Current. Oh no, so they're inversely proportional. Yeah, so the increases of voltage and current are inversely proportional. Because, as you can see, so this jump here from -5 to +5 is 10. Then from +5 to +10 is 5. So that's halving each time. Whereas this is -5 to +5 is 10. But then +5 to +30 is an increase of 25. So no, they're not. Man. Yeah, no, they're not. They're not. Get smaller. Wow. Of current get larger. Voltage is linear change in increase. Current is not. I don't know the component. I don't know the component. It can't be a thermistor. It can't be a LDR. It can't be. Could it be a filament lamp? No. I don't know. I think hopefully we can pick up some marks from the other stuff we did, but I don't know what one it would be. Don't know what component. Right. Figure 24 shows a circuit with a battery and 2 resistors. The resistor X has length 8 times 10 to minus 3 meters, cross-sectional area 1.2 millimeters. It's made of material of resistivity 1.5 times 10 to the -2 ohm meters. The battery has an EMF 3 and negligible internal resistance. The resistor Y has a resistance of 68. Calculate the current I in the circuit. What if, hear me out, instead I put the paper down and I walk away? No, it's not that bad. This is doable. So, first things first, we can figure out the resistance of resistor X pretty easily, actually. So, 1.2 millimeters is 1.2 times 10 to minus 3 meters squared. So, that's our cross-sectional area. And then we know the length, we know the resistivity, so we can say R equals 1.5 times 10 to the minus 2 ohm meters. The length is H times 10 to the minus 3 meters over 1.2 times 10 to the minus 3 meters, which gets us an answer of, if I put this in my calculator, 1.5 times 10 to the minus 2, 8 times 10 to the minus 3, 1.2 times 10 to the minus 3. So our resistance is 0.1 ohms for resistor X. Battery has an EMF 3, resistance has a resistance. So this is in series. It's just a very weird in series. So 68 plus 0.1 equals 68.1 ohms as our total resistance. I feel like I've done something wrong with order of magnitude. That seems like a really weird number. 1.2 millimeters squared is 1.2 times 10 minus 3 meters squared, right? I've not put in any wrong... No, nothing's wrong. No wrong numbers, I don't think. Rho L over A. Rho L A. Yeah, that's just a strange number to land on. Yeah, alright, okay, so... Yeah, total 68.1 ohms, because it's not... They're not in parallel there, it's just a very strange in-series. Because it's like... It's still heading this way. So they must still be in series, because there's not another terminal. So if we know, so we can use the equation V equals IR, rearrange for I, so V over R equals I, so 3 over 68.1 equals 0.044 amps. That seems low, but I've seen weirder amps, so it's not that strange. We'll go with that answer. It's an answer, so like I'll go with it. Right, 25. An oscilloscope is connected to a microphone. The oscilloscope is used to determine the frequency of the sound waves emitted from a loudspeaker. Describe how the trace on the oscilloscope can be used to determine the frequency of F of the sound waves. What if instead, I tore up my paper in front of my teacher? I don't want to do. Don't want to do this, man. I don't. This is. Yeah, man. I'm not vibing with this one. I'm not vibing with this one. Oh my god, we've still got so much left. There's still so much left, man. Well, F will equal lambda V. Will it? Am I lying, or will it? I'm lying. I'm lying. V will equal F lambda. Oh no. Frequency equals 1 over T. So T can be determined by measuring the distance between two points two equal points on the oscilloscope display. The time period will be shown on the x-axis. Convert the time to seconds, then find its reciprocal. Yeah, fair. Nah, that one wasn't as bad as it looked. Figure 25.1 shows two loudspeakers, L1 and L2, connected to the same signal generator. The loudspeakers emit sound of the same wavelength, but with different amplitudes. The points P and Q are at different distances from the loudspeakers. Why would they be there? That just seems bad. The sound at point P from L1 alone has displacement of x1. The sound from L2 alone has displacement x2. Okay, so we can't do I, so we'll just kind of mark that out. I would say can't do. We'll ignore that one when we come to marking. Because, yeah, I can't draw the variation. Explain why the intensity at P due to the sound from both L1 and L2 is not the same as the intensity of the sound P from only L1. That seems like a really, like... That seems like it's designed to catch you out, because it looks easy. Because my first thought was interference. If it's sound waves, they're going to interfere at a different point at P than they are Q. So they constructively. I'm gonna hedge our bets on constructively interfere at point P, meaning the amplitude and therefore intensity is increased. Okay, cool. The wavelength of the sound is 34 centimeters. The distance L1Q is 200 centimeters. The distance L2Q is 217 centimeters. Explain the type of interference occurring at point Q. But we want to find amplitude, don't we? So... Oh, wait, no, it's this weird equation. We've got to use the strange one. So lambda equals AX over D. I think if we look on here, we're not given anything. Never mind. I'm not even given a distance between the two. Alright, that's gonna be used for that, so we're not gonna bother with that. God, yeah, we're really not given anything to help with that. Because intensity equals P over A. Oh, is it just it's just explain? Okay. At point. Well, no, if they're let's see if they're in phase. Let's see if they're in phase. So, can you divide 217 by 34? No, you can't. Thank God you can't, because that would have been a crime. Can you divide 200 by 34? No, you can't. Fantastic. Great to hear. We're adding an extra half wavelength. Oh, no, it is. It is. Lambda equals AX over D. So D equals 217. Well, 2.17 meters. A equals 0.17, because it's the distance between L1 and L2. X equals... Oh, damn it. What does X equal? Oh, no, we're finding X. We're finding X. So 0.34 equals 0.17x over 2.17. So rearranging to find x, we get 0.74 equals 0.17x. So divide by 0.17. We get 4.34 equals x. And can you divide this? Can you divide 34 by 4.34? I'm actually an idiot. Of course you can't. So x equals 4.34 meters. So I don't know what that gives me, so I'm going to skip that question. Alright, 26. Figure 26.1 shows an arrangement used to demonstrate a particular your own revision in a random Newport car park. Great to hear. Demonstrate a particular... Double slit! Let's go! Sorry, I get really hyped when I see double slit because it means quantum physics is very close. We're so back, boys. So V equals F lambda. Wait. Why do we need to calculate the wavelength? Uh-oh. Is it really... Is it really V equals F lambda? Oh yeah, of course it is, yeah. Microwaves travel at the speed of light. Yeah. Yeah, so it's, so rearrange for lambda. So V over F equals lambda. So 3 times 10 to the 8 over, what is that, 11 gigahertz? Oh, that's 11 times 10 to the 9? Yeah, 11 times 10 to the 9. Which is... Naught point 0.03 meters. That seems really small. But you know what? I think that's right. Okay. The receiver detects no microwaves in the position shown in figure 26.1. The metal sheet is replaced by another sheet with a narrow slit of width of a few centimeters as shown in figure 26.2. The position of the transmitter, receiver, and the metal sheet are unchanged. Explain why the receiver now detects microwaves. Can I go past exams? God, I hope I do. I hope I do. Now we've got a bit more into this paper. This paper isn't that bad. It just kind of took me by surprise initially. I'm gonna hate this question. Yeah, screw this question. I'll tank the marks happily. But the rest of it, like, it's not that bad. But that either means I'm doing good or that means I'm being foolish. I don't know which one it is yet. So explain why the receiver now detects microwaves. So for waves to interfere, the slit must be approximately the same as the wavelength. Oh yeah, no, this does mean that I was correct, yeah, because it is only a few centimeters. Yeah, so the slit width must be approximately the same as the wavelength. So Yeah, so changing it to be a few centimeters makes the width similar to the wavelength. Yeah, I think that's about right. Right, okay, B. Light travels from air to water. The refractive index of water is greater than the refractive index of air compared to speed frequency. Oh my god. Shut up. Okay. So, yeah. I hate refractive index. So, okay. You know what? We're going to draw a table. We're going to draw a table, one air, and then one water. So, then we're going to have speed, frequency, and wavelength. Okay, so speed. In air, it's going to be faster. In water, it's going to be slower. Because if you kind of think about it, water is more dense. So you have to go through more of the thing to get to the other side. So you're going to go slower. Frequency. Stay the same. Should no. No. Could be faster in air. Slower in water. Because of the equation V equals F lambda. Which must mean wavelength is the same. Because wavelength is a constant. You can't change the wavelength of a wave when it's already waving. See a semicircle. So do I. As soon as a group in a semicircle. Circle. Describe the aid of a ray diagram. I unplugged my headset. Damn it. I hate ray diagrams so much with a passion. I hate them so much, man. Guess we gotta do it though. Damn, we got take 5 in this playlist? Ooh. Turn this up. It's about scheming music. Beautiful. Hopefully I don't get claimed by whoever made this song. Okay, ray diagram. So, oh, it's how an experiment could be. Oh man, I don't want to. I know it, but I couldn't tell you anything about it. I'm gonna skip this. I'm skipping this question. I'm skipping it. I'll tank the 3 marks. I'll tank them. I don't care. I'm tanking the 3 marks. Oh. Okay. This seems like a trick. X-rays have a higher frequency? Because, like, they do? They do have a higher frequency? Well, no, I'll say higher wavelength. They have a smaller wavelength. And radio waves, because radio wavelengths are insane. They're massive. Right. Procyon is a star of radius 1.4 times 10 to the 9 meters. The total output power of the electromagnetic radiation from its surface is 2.7 times 10 to the 27 watts. Average wavelength from the electromagnetic waves from Procyon is 5 times 10 to the minus 7. So the surface intensity of the radiation from Procyon is 1.1 times 10 to the 8 watt meters squared. Okay, so we're looking at the equation I equals P over A as our intensity. So, we know the radius, so we can do 1.4 times 10 to the 9 times 2 to get our diameter, then we can do pi d. Oh no, because a star's a sphere, isn't it? So we're actually looking at to find the surface area. We are looking at, where is it? Area of a surface area of a sphere. We're looking at 4 pi r squared. So 4 pi r squared equals our area. So we do 4 pi 1.4 times 10 to the 9 squared. So it's 2.5 hours. Yeah, yeah, you'll see, you'll see. Right, and then okay, so 4 pi 1.4 times 10 to the 9 squared gets us 2.46 times 10 to the 19 meters squared, and then we do 2.7 times 10 to the 27 over 2.46 times 10 to the 19 which gets us a big number, which we can put into standard form. Sorry, it has just genuinely come up as just a big number. I have to do it manually. So that's what, 100,000. Okay, so it's 109 million. So I'm going to just write this as 1.09 times, it'd be times 10 to the 8. Yeah, times 10 to the 8. What, meters? So minus 2, which roughly equals 1.1 times 10 to the 8 watt meters to the minus 2. We're so back! We're so back, boys. It's because of the space question. Can the edge of a photon of wave... Bro, shut up. Okay, so we got 5 times 10 to the minus 7 meters as our wavelength. We can do E equals hc over lambda. So that's Planck's constant times the speed of light over lambda, which is our wavelength. Love my brain is like all differential integration stuff here. That's fine. Coordinate geometry, nah. For real, I'm so good at differentiation and integration, but as soon as I see something that's like area of a circle, not area of a circle, like circle equations, like my brain is just like, nah, I'm not doing that. It's like, why? Oh my god, this player is just goated. Oh, this is literally... So you know how you can have a song on, like, your Instagram page? This is the song I have on my Instagram page. Sorry, I love this song. It's In a Sentimental Mood by John Coltrane and Duke Ellington. It is, bro. The saxophone is so good in it. It's this bit. It just hits, man. It hits. Right, okay, so E equals mc squared. So hyped to do that in year 13. We get to do Einstein field equations. And then 3 times 10 to the 8. And then 5 times 10 to the minus 7. So 3.98 times 10 to the minus 19 is what I'm getting as my answer. Joules, obviously, joules. Estimate the total number of photons emitted per second from the surface of Procyon. Well, okay, so if the power output is 2.7 times 10 to the 27 from EM radiation. Actually, yeah, no, we do need this. Is it work? Will we use work done? Because that's W. I have an idea. think this might work. So W equals VQ. Are we given the charge of a photon? No, we are not. Damn it. Okay, my plan doesn't work. I was going to use the charge of a photon. I was going to do W equals VQ. We are given neutron, photon. Oh, that's proton, not photon. I might be an idiot. Oh, that's a shame. Yeah. Okay. Yeah. So that's visible light. That's visible light. Maybe we need to use that. Because we're looking for the number. We use a calculator, but there's also a single question that says not to use it. Yeah. I mean, it's a 1 marker. Which means it's either really easy or really difficult. I think it is W equals VQ. Are we given a charge? Or are we're not really given anything. You know what? I might leave the question. Then. Right, there was another one I wanted to revisit that I said someone would remind me and no one did. It was, what, 23B? I just want to go back to 23B. I want to see if I can have another crack at it. Because this seems like it should be one that I should be able to do pretty easily. Hey, Lucky. Hey, no, welcome to the stream. Initial upward acceleration. My initial thought is Suvat, but it's not. Because you don't have anything else. I guess we can do 4.2 minus 0.8. .4 newtons as the difference. Could we get anywhere with that? F equals ma. Are we given the mass? No. We are not. That's a shame. You know, do physics in the weekend. Fair enough. I'm only doing this because I've got a test tomorrow. See, there's nothing on here that has acceleration except Suvat. Oh, that, yeah. I think we might have to leave it. Right. It's marking time. So, from question 21. So, distance displacement measured using a meter rule and a time measured using a stopwatch. Yeah, we got that. We did not get that, though. Actually, did we? No, we didn't get that. We got 1 mark. 1 mark. Okay, B, we should have got 2.1. We did not get 2.1. Ah, it was Suvat. Oh, damn. It was Suvat. Alright, we fumbled. Then that would have been 12 degrees. I don't even think we did that one, so. Right, 22. Yeah, 4.8 newtons. Yes! We got it. B. Drawing where at least 2 forces shown and 1 angle marked, and W side being longest. Did we get that? By some miracle, we got that. Okay. Yeah, we got this one. Hey, Tell, how you doing? Welcome to the stream. Energy 0.24 joules. Yeah, we got 0.23. Oh, do they allow that? I don't see why they wouldn't allow that. I've just got a more exact answer. Right, forces acted on tube. So up thrust increases because the weight of water is displacing. Right, we've got that one. We got that one. Bro, man, they're so picky. I am revising. Yes, I am revising. We got 1 mark, man. Then nothing for that, because screw that question. Resistive force? You know what? I said that. I said that. Yeah, I said water exerting pressure. That's like the same thing. Yeah. Power is 0.3 watts. Very nice. Easy 1. Okay. Oh, it was an NTC! It was an NTC, man! Oh. So you can scroll an entire restaurant now, but you wait for dinner. Yeah, wait for dinner. Oh, man, we fumbled that question. Now we got nothing. Alright, we identified the right equation. Oh, it's times 10 to the minus 6. Possible POT. Oh, we're saved on the POT error. Okay, so we still got 1 mark. Because that's power of 10 error. I got the wrong power of 10. Error carried forward. We're so back! Oh, we still get error carried forward marks! Oh, we still got 2 out of 3. We just messed up the answer. We actually somehow clutched 2 marks on that. Okay. B on this question. Was this one we couldn't do? Yes, this was one we couldn't do. Alright, so we ignore this one. We'll take this one out of the marking. So it's at this one. It's out of 49 now instead of 50. Because we couldn't do that one. Because we can't draw. The amplitude at P is smaller. Oh, guys, we fumbled that one. Okay, we fumbled. No, we didn't get anything for that one either. Now I need to revise waves more. Lambda equals 0.027. How they? What? Oh, did they? Oh. Okay. Yeah. No, we're good. We're good. We're good. Yeah. I was gonna say they didn't round. I rounded. They wanted 2 sig fig. Okay. For the waves to pass through the slit. We'll go 1 mark. We got 1 mark for that. Okay, speed of light is yes! Oh, frequency is the same! Oh, I got these ones mixed up. Right, we get 1 mark. C. I knew I was getting nothing. I knew I was getting nothing. I wasn't even trying. Alright, they were... They have different. I mean, I said X-rays have a smaller, which is correct. So. I mean, please tell me if I was wrong, but I don't think I was wrong. B. 1.1 times 10 to the 8. Yes, we did get that one. No answer mark, though, because it was a show that question. Double I. 4 times 10 to the minus 19. We got 3.98. Yeah. We're allowed that. Actually, they encourage that. Because, yeah, they say allow on there, which is like, give it, but that's not what we meant. So, yeah, another 2 marks. And then... Oh, it was that easy? Oh, man. Right, so out of 49 for this bit, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. So just under 50%. So 24 plus 13. So we got 37 out of 69. Yeah, 37 out of 69. Which is 53%. What year was this? 2018. So, AS level physics, OCRA 2018 grades. Alright, okay, so... Oh, this is A level. I don't want A level, I want AS. So for breadth, we'd clutch a C. We'd clutch a C. Fair. Okay. Okay, we'd clutch a C. Just about. Yeah, alright. Those questions were brutal, though, so fair enough. Alright, boys, you want to do another one? should we do another one of those? Let's get 2019. We'll speedrun this one. Okay, table below shows 4 physical quantities and their units. Which row is correct? Right, that one... It's definitely not that one, definitely not that one. B. Fortunes carry out experience of the association of freefall G, which is the least accurate value. Oh my god. This one. A. C. No. Wait, maximum compression. B. The variation with time T of the force acting on the ball is shown below. Which statement is not correct? Well, these are the same. So, they must be both correct. Which must mean that it's A. Yeah. Retain steam generator. Oh my god. Work done. I'm not sure. I don't know what a couple is. perpendicular distance between the nozzles is 8.2 times 10 to the minus 2 meters. What is the work done? Well, okay, let's look at what's work done. Work done in this context is power equals W over T. No, FV. I don't know. I'm gonna guess. We'll say C. We haven't had C yet. It's more of a variation. C, because it's LDR. A household is planning to change all their 60-watt filament bulbs to 12-watt LED bulbs. A household has a total of 10 bulbs. Each bulb used for about 2,000 hours in 1 year. C. I have seen that question before, and I know it is C. Oh. It's an object that angle theta to the force. The object travels 9.6 meters, and the work done by the force is 52 joules. So... Huh. Well, work done is force times distance. Is 12 times 9.6. No. What the hell? I don't know. Yeah, I don't know. I'm gonna guess. We'll say D. We haven't had D yet. Resistance of a wire of length L is 3 ohms. The wire extended so the length becomes 1.5. Its volume remains the same. What's the resistance to the extended wire? Right, so this is where is it? This is R equals rho L over A. So we can say that 3 equals rho L over A. If length stays the same, no, everything else stays the same, except that. So that's now 3. That's, you can call that 3 over 2 because it's increased by a half. So you can say it's 3 times 3 over 2. So 4.5. So C, I think. Oh, potential dividers. My god, it's been a while since I've seen one of these. Okay. So the minimum resistance of the variable resistor is 0, and the maximum is 3R, where R is the resistance of the fixed resistor. The power supply is an EMF of 4, and the voltmeter has infinite resistance. My god, damn. This is the variable resistor change from the minimum to the maximum value. Okay, well, so this is V1 over V2 equals R1 over R2, I think. Yeah. So 4 over V2 equals R over 3R. So 4R, well, 4V is going to be in there somewhere. If it's at lowest resistance, it's going to be at highest voltage. If it's at highest resistance, it's going to be at lowest voltage. So it's going to be going up to down. But none of these are up to down, so it's going to have to go down to up. Oh no, sorry, void is going to increase. It's going to increase. It'll go from 0 to 3, I think. I think it'll be a B. Right, 11. Covering of wavelength 10 centimeters. The waves are in phase at X and Y. Correct conditions for constructing movements are into point Z. Okay. So if they have wavelength of 10, that means one wavelength is 10. One wavelength is, so they're coherent. They're in phase at X and Y. Alright, so that means they are that. So if they're in phase, that means that they have the same. They have their phase difference is 0. So I don't know, man. My brain's kind of fried. I need to revise more raves. You know, should we call it here? Let's mark what we've got, and I think I might end stream. I don't think we need to do another whole past paper. So we did questions 1 to 10. Let's see. Okay. So B. A. B. A. It was D. C. C. Then it was D. Then it was D again. And 10 was B. So we got 7 out of 10. Yeah, I'm gonna call it there. My brain's kind of fried. I need a little bit of a break. I need to eat dinner and all that stuff. Thank you all for watching. This has been imperative to me passing my exams. I'm praying I do now. But yeah. Waves is the next thing I need to revise. But thank you all for watching. Keep on gaming. Stay safe. I'll see you all on Tuesday for the pre-birthday stream. Anyway, thank you all for watching. I'll see you all soon. Bye-bye.